In this video, we're going to look at directional derivatives, but with the viewpoint or the information coming from a contour diagram to define our surface. We'll be working with this contour diagram here, and notice that it is a contour diagram for a linear function. We can tell that because all the contours are straight lines, they are all evenly spaced, and that matches with the evenly spaced z values associated with them. We can see that this is the top of a hill, then this is going downhill as we move towards lower and lower z values. We're asked on this diagram then to make some interpretations. Mark three directions, u, v, and w, at the point P, so we're here as our reference point. Here is going to be our new notation. This is the slope, the derivative representing slope of f, there's our f, in the direction of, in this case here, the u vector. So all the slope interpretations we've seen earlier, we're going to add here into this notation. And the idea is we take our reference point and we move away in some direction. And we ask, in this case here, that when we make that move, that we find ourselves going up, specifically the slope of f in the direction of u. So if we imagine ourselves here, we already saw that these numbers are going down as we move up and left on this xy plane diagram. So if we want to move uphill, we could pick maybe this direction here and call that our direction u. Notice that that is not the only choice. We could also go this direction. We're still at height 6 heading towards height 8, but it's still going to take us uphill. So there's more than one choice if we're simply looking for a positive slope. If we look for negative slopes, you can imagine pretty easily that we go in the other direction. And we can also go in several choices there. We could go in that direction, or even over here. All of those are taking us from a height 6 down towards a height 4 eventually if we follow that path. And last but not least, we can feel it already happening if we talk about a direction where the slope is 0. Well, that requires staying at the same height we're at now. We are currently at height 6 because we are on this contour. The only way to stay at height 6 is to follow that contour. So if we take a step along this direction, imagining this line as a road, the special thing about this road is that it would be a perfectly flat road if we followed it. So we can pick W to be along that direction. We're going to stay at height 6 forever. Here, there is another option. We could also take W going along the contour in the opposite direction, but there's no wiggle room for it. If we go even a little bit off that path, we're going to end up with either a negative slope or a positive slope. So this is going to be a transition direction between the positive and negative slopes. Not too surprisingly, it's the 0 value is going to happen between negative and positive slopes. Let's imagine that same conversation happening now on a more rich contour diagram. We can see that there's a peak in the contour diagram here because there's a height of 85, and things are going down and then down towards this corner here. Using the same approach as before, noting our point is A on this diagram, we imagine directions on the plane where if we travel in those directions, we go uphill. Well, that's pretty clear again with the interpretation of this being the peak. If we were to go in this direction, or this direction, or this direction, all of those would correspond to uphill directions. Correspondingly, we can talk about downhill directions. Pretty much any direction in that orientation or that half of the plane would satisfy the slope of our function in the direction of v being negative. And last but not least, this gets a little more interesting. If we're looking for slope 0, remember that we're going to define our direction with a vector of length 1. So we draw that as a fixed size. However, the step in the direction of w is going to be infinitesimal because we're talking about slopes, and these slopes are tiny steps in that direction. If that's the case, then as long as we draw, clean this up just a hair here, as long as we are tangent to that contour, then we imagine taking the smallest possible step in that direction then we would be staying on that contour line. That's more obvious on this side. We would have the vector not towards this line, but tangent to that line, because then we take a small step in that direction, we're going to stay on the contour. And so those W directions become the directions which, if we took a microscopic step in those directions, we would have zero change in our height, and so we'd have zero slope as a result.